Assalamu alaikum and hi doctor. Uh, I'm Kamal bin Amal and I will be doing the introduction part for our project which is underwater image restoration. So we are three members in a group. Okay. We have Muhammad Hatta, HAZIM SYAHMI and KAMAL myself. Okay. So the problem background of this project is basically about underwater images. Okay, so underwater images play very crucial role in a wide range of fields like marine biology and oceanography and also underwater exploration. So these images provide us with valuable insights into the underwater world, enabling us to study marine life, understand the ecosystem, and monitor environmental changes. However, these underwater images suffers from degradation, okay, due to factors such as poor visibility, scattering, absorption, and color distortion. These factors significantly affect the clarity and quality of underwater images, making it challenging to extract accurate information and analyze the scene efficiently. Okay, so in our project, we have specifically focused on the analyzing the effects of Gaussian noise on the underwater images. Okay, Gaussian noise is commonly encountered, which is a type of noise characterized by a bell-shaped distribution. Okay. By studying its impact in underwater, we have gained insight into how Gaussian noise degrades image quality and introduce unwanted variations of blurriness which affect the important details of the image. Okay, so the goal here is to restore the underwater image, denoising it, okay, by using several techniques, okay, to remove the noise effects caused by various sources and ultimately improve the image quality. Okay, next I will pass to my teammates.
So next we have the methodology part. So here we have the flowchart of our project, which started with noisy underwater image, and then we'll be performing image restoration process and also the image enhancement process. And then by then we can have the restored image. So first thing first, we're going to select an underwater image, which is the original image, using the file dialog that will appear. Um, then we will apply the Gaussian noise with density ranges from 0 to 0.5 to create a corrupted version of the original image or corrupted image. And next, median filter will be executed, which will be applied to each of the individual channel, which is red, green and blue, separately using a 7x7 square median filter. And then we will apply the histogram equalization to enhance the restored image contrast. And lastly, gamma correction will be used to further enhance the image by adjusting its brightness and also visual quality. So next we have the apply Gaussian noise part. So as you can see here, we are using the Gaussian type noise, which ranges from 0 to 0.5. This is not the updated code. And then we have the apply median filter part. So as you can see here, we are applying the median filter one by one to each individual channel, which is red, green and blue.
So next what we have done here is histogram equalization. Okay, so this is a method used to enhance the contrast of the image by distributing the pixel intensities. So in our project, we have applied the histogram equalization on the previously median filtered image here. By doing so, we improve the visibility and distinguishability of various features within the image. Okay. The resulting image, equalized image will exhibit a wider dynamic range, making it easier to perceive the details and patterns. Then we use IMShow function here to display the equalized image. So we can compare it to the previous image. Next, what we have done here is performing gamma correction. Okay, so we apply this technique to further adjust the image brightness and contrast. Gamma correction is particularly useful in compensating for non-linearities in the image system. Okay, so in our case, we have chose to apply gamma correction the factor of 1.2 here. This is applied to the equalized image before this one. Okay, so this will fine-tune the brightness and contrast level, enhancing the overall appearance of the image. Again, we use IMShow command here to visually assess the improvement achieved through this correction. Okay, this will display and we will assess the improvement. Overall, the combination of these techniques, okay, plays a crucial role in further enhancing the quality and appearance of our restored underwater images. Okay, these techniques will help us to bring out the details, okay, improve the contrast and optimize the visual characteristics of the image. Next, I pass to Hatta.
Thank you, Kamal, and I'm going to proceed with the output. So this is the image that we used for underwater image restoration. So as we can see that in the corrupted image, which we applied a Gaussian noise for the image, as we can see that the image is much more clearer. And after that, we enhance the image with histogram equalization and gamma correction. For the noise density of this one, we use 0.2 density, and for the restoration, as we can see that the corrupted image, we cannot identify which is which of the coral, and the detail of the coral also unidentifiable. After restoration, we can see clearly which is which, but it's not clearer and the detail is not even there. After that, for the enhancement, you can see that the corals is much more clearer and we can get as much information as possible for the coral. But the drawbacks of this underwater image restoration, if the noise too high for the corrupted image, like this one, we use 0.5 of noise density, and I try to get the optimal filter size as optimal as possible, and this is the best image that we can have. As we can see, in the noise part, we cannot identify which is the background, which is the fish. And after removing the noise and enhance it, we can pinpoint the fishes in the coral reefs. So the conclusion of this project is we have successfully figured out how to solve the Gaussian noise problem on underwater image, which we applied median filter. We enhance it with histogram equalization and gamma correction. By using different filter size and different density of the noise, we can find the most optimal one for the image. Judging by the result, Gaussian noise massively changed how the image was supposed to be, and by restoring it, we can gather as much information needed from the possibly corrupted underwater image. And these are the references that we made for this project. Thank you.